All right, good evening, students. Good evening.
Even so,
Good evening, sir.
Everybody okay? Everybody good?
yes, sir.
Yes, sir. How are you?
I'm doing well. I'm doing well. All right, guys. It's 7:05, our usual starting time. I think about four persons are absent, are them late, so they're gonna chip in a few. I did see a few new names in my class. I'm not sure who these persons are. So, is there any new student in the class today? Anybody is new? I see a new name earlier. Not sure. I know Tashiels, I know him. I know Shanika, I know
I'm a new
Nivea.
student, sir.
Mikida. Are you new, Mikida?
No, sir, it's Kevin. I'm using my mother's account.
Oh, okay. All right, that was the only unfamiliar name. So my usual students are here. All right, so good evening, everybody. We are going to jump into our session for this evening. And we're going to be picking up on the topic that we had completed last. Well, we closed last week Thursday's class on the topic of measurement. Can we recall that?
Yes, sir.
All right, so that means for this Wednesday now we're going to pick up from where we left off. But the usual routine is always to do a quick recap, just a little refresher. Remember that recording is available on my channel. So should you need a refresher, some reiteration, just a recap, just to keep your mind fresh, the link is always pinned. All right, the link is in the group, so you can access that session at a time convenient to you. All right, but to jump into the session, we're going to have to, just do a little refresher, right? A little oral refresher. So let me just begin to share. Oh, my screen is being shared already. So give me a second here. All right, so I just want to take a 2 minute here just to just share with you a little thought, right? I'm evolving as a teacher. I'm learning better ways to teach, to bring across the lesson. You guys are the ones that are giving me that opportunity to become a better teacher. So, as I feel like I'm getting better, I want to share little tips and pointers. Now, over the years, I've always my students come to me on a regular and be like, sir, the hardest part of math is there's just too much formulas. I can't remember all the formulas. And one of the reasons why you may have challenge in remembering formulas in math is because you guys are memorizing the formulas mentally, right? It's like you learn a formula today, you're not writing it down. You're not writing down stuff. You need to write down stuff. You need to if you want to evolve as a student, you have to take it serious in terms of color code you're learning. So you buy some sticky notepads that you can find in any convenience store, and you stick up your book. So you have a pink. So every time you see a pink slip or a pink sticker note in your notebook, that's related to measurement formulas. Then you have a green sticky note that represents algebra formulas, and then you have a green sticky note that represents matrices formulas. So you sticky up your book. So I want to share stuff. What I want to, the point I'm trying to bring across, guys, is take some of the clutter. Remember, your brain is it's like ROM and RAM, random access memory, read-only memory. You have to clear clutter for you to put formulas. A lot of you guys have so many unprocessed formulas that you remember from 10 years ago. Write it down, guys. Practice to write stuff down. Once you start to write stuff down on paper, then you clear your brain for learn more new formulas, because it not gonna stop. It's just going to get worse. To put it nicely, it's going to just get worse because you're going to learn more and more formulas. Some you may not have to remember because you get helpful formulas on the exam paper, whilst some you will have to remember. The ones that you have to remember, write them down. The more you write, this is why when I'm teaching measurement topics, I always encourage students that once you begin the question, write your formula down. Don't try to do it or guess. Write the formula down and let the formula tell you where to go to next. Okay, so just a little tip. There's something that I picked up while I was watching YouTube today, and I feel like maybe can help somebody in the class, right? So practice, guys, too. Write stuff down. Write it down. Anything that you feel like it's too hard, write it down. Write it down. Have a 5 corner in your room with sticky notepads. So every corner where you go, you book up on one formula. This is how you're going to surround your environment with, making math easier, if you want to call it that. Okay, so that's just a little tip for you. Hopefully it helps somebody tonight. But let's jump onto our main conversation for tonight, which is the topic of measurement. All right, so in our last class, we were exposed to 2 new formulas. For some of us, that formula is, you've heard it before, right? A couple of years ago, a few months ago. And for some, it's kind of new, because there's some persons that generally never get a chance to learn math from the basics. So to recap that, we know that we learned about 2 two-dimensional shapes last week. And that was in fact the square. We learned about the rectangle. And so for the square, just a quick review, all the sides are equal. And all the angles in the corner measures 90 degrees. All right. Now for the square, we don't distinguish between the length and the width. All the sides are the same, so we just label them as L, L, LL. Now, the area of a square is the side by the side. So as opposed to writing the word side by side, we just write length times length. Now, in our previous class, I explained to you why I would prefer you using L squared as opposed to L times L, because when you get a reverse question, there's an ambiguity about using the formula that could potentially lead you to the wrong answer. So if you want to avoid having to deal with that at any point, it's best if you use A is equal to L squared. For the rectangle, we know that the length, if you want to call the length the long side, that's up to you, and the width, the short side, it doesn't matter. Once the orientation changes, the length and the width, it has no bearings on your answer because of the commutative law. Different business act, another day for that discussion. So in this case, then it's still side by side. So we then say that the area of a rectangle is the length multiplied by the width. All right. And, yeah, that's it. We can say A equal LW as well. All right. For those who know algebra, when 2 letters are joined together without an obvious sign, it implies multiplication. So then this will be that. So those formulas, so we write them down, right? I constantly repeat them and they will become a part of you. All right. After a while, you say it 1, 5, 6 times, you finally you get it. It's like it can't leave you no matter how hard you try. All right. So if you want to get some questions on that, as I said, I have a worksheet coming up. So it will have a bunch of these application questions on it. Okay. So you can check out the examples that is available when it's released. So now we have to move on to next in line would be for me, right? I do the discussions in a sequential order. So I usually go from square to rectangle, then from the rectangle to triangles. Okay. So the prefix tri means 3, right? So a triangle is a shape, and it's a shape that contains 3 sides. Triangle, 3 sides. So I'm assuming that everybody here has done math at some point in their life. So obviously we know that a triangle looks something like this. Now, there are different types of triangles, and they're based on the different types. Well, the name of the triangle is depending on the information that you have about the triangle. So I'm going to go ahead and I'm going to draw 3 triangles. All right, they're going to look almost the same without the measurement. So I'm going to draw a blue one. I'm going to draw a red one. I'm going to draw a black one. And then I'm going to draw, let's switch out the color I can use here. We're going to draw a green one. Oops, that didn't work. Hold on, guys. Okay, I got you. Then we're going to draw a green one. Oh, let me be specific with this green one here. Good. So for the blue triangle, if I go ahead and I say for the blue triangle, if I say that this side, whoops, hold on, guys. Okay, here we go. All right, so if I say to you that this side, and this side are of the same measurement, that means if this side is 10 centimeter, then this side is also 10 centimeter. And then this side is also 10 centimeter. If it so happens that this is the situation that you see on your assessment paper, then it would mean that you are dealing with an equilateral triangle. So this triangle is called an equilateral triangle. And the prefix equi means equal. And so an equilateral triangle is a triangle where all its sides are equal and all the angles are equal as well. Now, this is the only triangle where even if you're not told what the angles are, you automatically know what the angles are, because this angle is 60 degrees. And then all the other angles measure 60 degrees as well. So this one is also 60 degrees as well. That's the only triangle where you can safely see what the angles are without being told. All right. Now, for the red triangle, so for the red triangle now, I'm going to say that only this side, oh, this is a bit too much. All right, so for the red triangle, I'm going to say that this side and this side are equal. All right, the other side is not the same length. Only 2 of the sides are equal. Then this triangle is called an isosceles triangle. And so with an isosceles triangle, not only are there 2 equal sides, but there's also 2 equal angles as well. So this corner is equal to that corner. Now, we don't know what, we just know that they're equal, but we don't know the angle. right? We can't make an assumption. We can't say it's 30 or 45 or 60. We don't know. No, we don't know. We just know that whatever one is, the other one is the same as well. So, in summary, then, an isosceles triangle is a triangle that contains two equal sides and two equal angles. Now, be mindful, guys, because when it comes to the isosceles triangle, I'm not saying that it's always this side and that side that's equal. That's not what I'm saying. You have to also understand that the equal sides can come from any direction, any orientation. So therefore, then, if I end up saying for this black triangle down here, if I end up saying that this side and this side is equal, then the equal angles, well, basically this side is looking at that angle and this side is looking at that angle. So these are the two angles that are equal. Let me show you which two angles are equal. So it would be this side is equal to that. So this angle right here, and then we have here this angle here. So these are the two equal angles, this one and this one. So the equal angles are basically facing the equal sides. Okay, so that's what I wanted to clear up. All right, let me just redraw this here. Okay, so let me redraw my.
The Roxanne need to be let in.
Okay, just a second, guys. All right. All right, so let me just redraw my black triangle here. All right, so the other triangle now is where none of the sides are equal. None of the sides are equal. So each side has its own independent measurement, own independent dimension. So no sides are equal, which therefore means that no angles can be equal as well. If that situation comes up, then this triangle is called a scalene triangle. All right, and then now we have this green one. And this particular triangle seems to have, I think a lot of the math that we know as it relates to shape, I think most things are derived, by a conversation being held about this specific triangle here, guys. This specific one here. It's drawn this way. Now, this triangle is a triangle that contains, let me see here. Let's put a little box in the corner here. There. All right. Now, that box that we've drawn in the corner here, it symbolizes a very specific angle in math. And that angle is equal to 90 degrees. Not 91, not 89, 90 degrees. And so this triangle gets its name based on the fact that it has one 90-degree angle. When a triangle contains a 90-degree angle, then this triangle is called some will say right-angled triangle. I just simply say right triangle. That's just what I call it. I don't say right-angled triangle, and I feel like that's redundant. So it's called a right triangle. Okay, that's how it gets its name. Now, there's just to put it out there, right? Just to put it out there, there's nothing called a left-angled triangle or a down-angled triangle or an up-angled triangle. No, we don't have that. So regardless of the orientation of the right angle triangle, whether it's turned this way or it's turned this way or it's turned okay, it's gonna this way. The orientation has nothing to do with the name of the triangle. It's called a right angle because it has a 90 degree, a 90 degree, and a 90 degree. All right. Now, majority of, I find that at least 20 to 15, 20% of the things you're going to learn in math, it's something, I would say that it's mostly we talk about the right angle triangle. We don't talk about the other triangles like how we talk about this one. Because this particular triangle is the only triangle that its sides have a name. And we don't want to have that discussion in this class, right? Some students will know that they're called opposite, hypotenuse, and adjacent. That's when we reach trigonometry. We don't reach here so yet. So it's the only triangle where each of its sides have a very specific name based on the angle that is in the question. But for now, we just have focus on perimeter, and we're just going to be focusing on the area of the triangle. We're not going to be talking about the lengths or the angles, just the fact that we want to find its area. Now, since we have gone through all the different types of triangles and their properties, then we have to move into how do we find the area of a given triangle. Now, a lot of you guys, of course, a lot of you guys here, if I were to come out and if I were to ask a person at random, all right, I'm gonna test it. Right? If I were to ask a person in this class at random, just pick a name out of the group, just out of my head, who I remember. All right, and provided that this person has done math at some point in their lives, I'm gonna ask them to say what they think the area of the right angle triangle is, and I'm going to copy them at the same time. And I don't know what this person is thinking. So let's just pick Miss Barrett. That's just the first thing that comes to my mind. Miss Barrett, you've done math at some point in your life, right? So if I were to ask you, what is the area of a triangle? After 3, you're going to tell me what comes to your mind. If you don't know, say I don't know, sir. All right. So after 3, 1, 2, 3. Half base times height.
Height.
Is that what you're thinking?
Yes, sir.
Is that what came to your mind?
Yes, sir. I already know that one.
All right, good. So me and Miss Barrett don't have any conversation about what she was thinking. So how did I know that? Because what I noticed that when you learn certain formulas in math from a tender age, I don't think them specify enough. Because all of us know that the area of a triangle, at random, somebody's going to jump out and say half base times height. Well, here's the actual truth. The area of a right triangle is half base times height. So basically, this formula that we've been walking around with and saying area is equal to half multiplied by base multiplied by height is really the formula for finding the area of this specific triangle. That formula cannot be used to find the area of a scalene. It cannot be used to find the area of an equilateral triangle. And it cannot be used to find the area of, I said, scalene, equilateral, or isosceles. Because it's not all the time you're going to get a triangle that has a base and a height. You may get a triangle that has a base, but you don't know the height. There's a height, but you don't know what it is, and you can't find it. There's not enough information to help you to find it. So what are you going to do then when you're asked to find the area of a triangle that has a base, but it doesn't have a known height? You can't use half base times height. So this is why then it's safe to say that this particular formula that you guys are familiar with is really the area for the, is really the formula for the area of a right triangle. So the next question begs is, sir, is there a scalene formula? Is there an area for a scalene triangle? Is there a formula for that? Is there a formula for the area of an equilateral triangle? Is there a formula for, are you then saying, sir, that since there are 4 right angle triangles, since there are 4 types of triangles, are you then saying that there are 4 formulas? No, that's not what I'm saying. Here is the actual understanding of the formulas. A triangle doesn't have a formula per se. How we decide which formula we use is dependent upon the information that we knew about the triangle. So with this triangle, we know that there is a height and we know that there is a base. So since we know the height and we know the base, then we have to use the formula that contains the base and the height. Watch this now. What if we then end up with a triangle that just looks like this, where I know what this side is, and I also know what this side is, and I also know what this side is. So in this example then, I know what all three sides are. I am given the actual dimension. So I could say that this side is 10 centimeter. This side is 7 centimeter. And this side is 9 centimeter. Let's just say, hypothetically speaking, that we know what the sides are. How can we use half base times height? What would you call the base? What would you call the height? Now, bear in mind that height can be vertical, height can be horizontal, and height can be diagonal, depending on the orientation of the shape, meaning the direction where we turn the shape. One thing though is that the height, if the base is horizontal, meaning that the base is like this here, so down here. If we know that the base is horizontal, then the height has to be vertical. That's one thing for sure. So in this example, we do not have a height. We don't have a known height. Then, sir, can't we just use the ruler that is in our geometry set to measure it? No. Most diagrams on an exam paper are not drawn to scale. So there's no ruler measurement that can be applied. So then there must be another formula. Well, there is. And this formula was derived by, I don't know his first name because I've not studied like the history of math, but we know this formula as being the Heron's formula. That is H-E-R-R-O-N-S. Heron's formula. Now, before you say, sir, why too much formula, yeah, man, me can't remember the formula then. Here's good news. The formulas that are being shared with you tonight are formulas that are provided to you by CSEC at the front, at the sheet that is in the front of your question booklet. So the good news is, it's good news, but it's bad advice. Good news is that the formulas are given to you. The bad advice is that I'm telling you, you don't have to study it. That's a very bad advice because, we encourage you to study the formulas. But you can save some space in your brain to put other formulas and just focus on what was not given, what is not provided. So like for this, you go to the front, you open your question booklet, you look at the formula sheet at the front, you look at the bottom of the formula sheet, and you'll see area of triangle, Heron's formula, what I'm going to show you now. All right. All right. So what exactly is the Heron's formula then? Heron's formula contains two parts. We're not going to be proving how it was derived. CSEC doesn't really ask you to prove stuff. They just say, here's the formula, use it, get to the answer. So Heron's formula then it has two parts. First, you have to find something known as S. And S means semi-perimeter. Now, the prefix semi means a half. Perimeter. So S means semi-perimeter. And semi means a half, perimeter means distance around. So if I have a shape with all its sides, and let's say that the sides name A, B, and C, then I can safely say then that S is equal to this side A plus this side B plus this side C divided by 2. So the division by 2 is because it's the semi, and the A plus the B plus the C is because it's the perimeter. So the semi-perimeter is the sum of all the sides divided by 2. Now you have to obtain that value first before you can proceed to finding the area of the triangle. So then the A part of this formula then, pardon me guys. So the A part of this formula then is going to be equal to the square root of S bracket S. Let me just get some space here, guys. Hold on. It's going to be a little bit lengthy. Give me a sec. I think I lost my page. Just a second, guys. Okay, I think this is it. Yeah. All right, so that's a little bit lengthy here. So the formula is going to be A is equal to the square root of S bracket S minus A bracket S minus B bracket S minus C. So that is the A part of the formula. So if you notice that in the A part of the formula, there is a value S, not 5, guys. I know my handwriting is a bit atrocious, but that's not 5, that's S. We need the value of S. If you notice that S is repeating itself 4 times. So we have to find S before we find A. So S would be your semi-perimeter. A, B, and C would be the sides that are given. Sides that are given in the diagram. All right. Now there's a third formula, but we don't want to create a clutter. So we need to apply what we're learning. We need to apply what we're learning to an actual question. Okay. So let's jump into it. Oh, before I actually go on, is everybody clear? Everybody is comfortable with the discussion already? Are there any questions?
Sure, it's like a SR5.
That's a S, Damoy. We just said that. S. Handwriting is bad, but it's an S, not a 5. Any questions from anybody? Everybody good?
Yes, sir.
So far, good. All right, so let's get to a fresh page. So now, I have this diagram drawn on the exam paper. And on the exam paper, we happen to pounce upon this question where this side is 9 centimeter and this side is 4 centimeter. And we don't know what that slant side is, and we don't really care. But the question says, 1, find the area of, and they have a tendency to name the vertices of the triangle. So they like to say that this point is P, this point is Q, this point is R, and then they'll say find the area of P, Q, R. So in other words, you're trying to say find the area of the triangle. Now, we can confirm that this is a right angle triangle because of the box in the corner. And this triangle obviously has a base and it obviously has a height. So then to find the area, we would draw for our formula A equals half base, half times base times height. All right, now A is equal to then half multiplied by the base, which is 9, times the height, which is 4. Now, it's easier to find a half of an even number than it is to find half of an odd number. Not everybody is going to know right off rip that a half of 9 is 4.5. But everybody's going to know what is a half of 4. So as opposed to saying a half of 9 times 4, I can simply say half of 4, which is 2, and 2 times 9 is 18 centimeter squared. And if you can't bother to do it in your head, because math is not enjoyable for everybody, you just simply go on your calculator, you multiply 9 times 4, which is 36, and then find half of 36, which is 18. Now, I like to make math as simple as possible because, as you learned last class, that is not all the time you're going to be asked to find the area. And I find it easier working with whole numbers than working with fractions. I can work with both because obviously I have very good math foundational skills. But for the average person who just wants to keep things simple, right? As opposed to using the formula A equal half base times height, I would implore, I would encourage, I would advise, I would prefer if you say area is equal to base times height divided by 2. Once I have it this way, I don't have to deal with a fraction. And it's just kind of a mental thing, right? For some of you guys, it will not affect you. For others, it may. So I feel like it's easier if you say base times height divided by 2. So I'm just telling the class that this is how, or this is the way I'm going to be using the formula. All right? So I'm going to be using A equal B times H divided by 2. So it's the same formula as half base times height. All right? So just letting you guys know that. All
Sir,
right,
it's
then.
supposed
So,
to be centimeters square.
yes. Wait, hold on. Where did my diagram go? Oh, there it is. Yes, so it's supposed to be centimeter squared. Yes, Jordan. My apologies. And I appreciate my students holding me accountable for any error that I may make. So that's good. All right, Jordan, this is your focus tonight. All right, then. Good. Now, let's look at the question now where you're not asking you to find the area. All right, so I'm going to give you in a worded form. Okay, I'm not going to write it on screen. I'm going to dictate the information. So take this down for me, guys. Triangle ABC, ensure that ABC is all capital letters. Triangle ABC has an area of 110 square centimeters. Has an area of 110 square centimeters. And its base length is 13.2 centimeters. Is 13.2 centimeters. Calculate the height of this triangle. Calculate the height of this triangle. Question: what kind of triangle is this? Is it a scalene triangle? Is it an isosceles triangle? Is it a equilateral triangle? Is it a right triangle? What triangle? It's a right triangle?
Yes, sir.
You think so? How do you know?
Base.
Did I say it was? You can't just assume that it is, What information is in this question that allow you to make that mathematical assumption?
The base length.
Very good. It's the fact that I said that it has a base length, and I'm asking you for the height. There's only one triangle that is in our triangle family that contains a base and the height. If I didn't mention anything about a base, if I didn't see the word base or see the word height, and it just says that triangle ABC has lengths, blah, 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 then it would not be a right triangle. But the mere fact that I said its base length is and calculate its height, then you can confirm that it's a right angle triangle. Now, if you want to draw a picture, guys, that's good. Right? I do believe that a picture tells 1,000 words. So when I get worded questions, I try to transfer the words into a picture. So for me, I'm just going to just sketch my triangle. I'm just going to just say that my right angle triangle here looks like this. I'm just going to say that. All right. And then according to the information about the question, it did say that the area is 110. So that means inside here is equal to 110 square centimeters. And also, according to the information, it did say that its base length is 13.2 centimeters. So basically, we're looking for the height, which we can label h, or we can just say that the height is x. So we're looking for x. All right, which one of my 21 smart students can tell me how I would start this question? What is the rule that I gave you in our last class that will ultimately lead you to the answer without you even trying? Which one of you guys can remember what is it that I tell you to do every single time to start this question?
Sir, apply the formula first.
Apply the formula. I think I wanted to use a different word.
Write
Start.
down the formula.
Music to my ears. Write down your formula. So Jordan, we are going to apply the formula. But what you want to do to start the question is always write the formula down. And in this case, since we're talking about area, then we know that we have to say A is equal to, and I'm using the one that I like, guys, base times height divided by 2. Now, we're going to take the information that is given to us about the triangle and insert them in its respective position. So if them give us the area, we're going to replace the letter A with the number that represents the area, which in this case, we're going to have 110 here. Then that's going to be equal then to, continue, B represents base, and in this case, we know that the base is 13.2. So that's equal to 13.2. And then we know that we are multiplying it by h, which we don't know, but in this case, h is represented by x. In fact, here, when I use x, I am going to use h. So 13.2 times h, because the x looks like the multiplication sign. I don't want to confuse you all. And then we divide that by 2. All right. Now, there is nothing that we can really do. There's nothing to do on the left side of the equation. But on the right side, there's only one evident thing that we can do here. And that is to simply divide the 13.2 by 2. So we're going to divide the 13.2 by 2. Can you confirm what's the answer, guys?
6.6.
So 110 is equal to 6.6 times h. We divided the 13.2 by 2, so the 2 disappear. So we get 6.6 times h. And then from here now, we just simply do the opposite of the operation that is on the right. The 6.6 is multiplying the h, and so we know that the opposite of multiplication is to divide. So then our answer is going to be 110 divided by 6.6. And that will produce the result of h, which is the height. How much you got, guys?
16.66.
So 16.66, which you can just say 16.7 or 16.67, or doesn't matter. The question will specify, say, in 1 dp or 2 decimal places or 3 significant figures, whatever. But if you're not told, keep it simple, 16.6 centimeters or 16.7, preferably. Round it off. All right, is it clear, guys? Simple enough, no?
Yes, sir.
So I kind of
Simple.
lost you.
You said you lost me at where?
I lost you at 110 equals 6.6 times 8.
So the question at that point is, what is the opposite of the sign that you're looking at? What sign are you looking at the right?
Because
On the right.
my stream keep going in and out.
Oh yeah, but I mean, if it does that, then you know that you're missing out. So you have to try to get that stable.
Even though it's I don't know.
Yeah, well, you have to stay on screen, Miss Cherry, in order for that to be solved. You have to fix that. So you're not lost, you just didn't see. So you have to try to get the view on that. You have to get it stable, okay?
Okay.
All right, so that's the direct question, finding the area. Then you get a reverse question that asks you to find either the height or the base. So then that's pretty much what they can ask you for at this stage. No? I can't ask you to find the third side because that would need a trigonometrical formula, which is called Pythagoras theorem, and we're not there as yet. So we're just focusing on the area. Let's then move on to another diagram. So then we have a triangle that then looks like this. And I'm just going to say that this side is 10 centimeter. I'm going to say, oops, I don't want that to look too funny to the viewers. So it's 10 centimeters. All right, and then at the bottom, we could say that the bottom is, say, 12. Let's just say 14 centimeter. And let's say that the other side is, let me just check this in my mind. That's going to be 24. That's going to be 36, 18. Okay, so let's just call this, say here, 12 centimeter. So one side is 10, one side is 12, and one side is 14. Now it's very, and oh, sorry, pardon me. The question is, find the area of, again, they like to label it, X, Y, Z. So find the area of X, Y, Z. So find the area of XYZ. XYZ is not a right angle triangle because there's no indication of that box in the corner. So we can't use half base times height because half base times height is the formula used to find the area of a triangle that is a right angled triangle. This is not. So we then have to move to another formula that may be available on our formula sheet at the front page of our question booklet on CSEC examination. We would therefore turn to this gentleman here by the name of Heron's formula. So Heron's formula, we know that there's two parts to it. You need to find the value of S. And in this case, as usual, guys, I'm not going to deviate from what I told you to do. I'm going to do it even if you don't. I have to lead by example. A plus B plus C divided by 2. So, sir, can't I just go ahead and just add it and get my answer? Of course you can. You're not getting any extra marks to write down the formula. But this is how I teach. Write down your formula and then proceed to your calculation. So we have S is equal to any side, Miss Cherry, can be labeled A, any side can be labeled B, any side can be labeled C. So in this case, whatever you call A, B, and or C has no effect on your answer. So this time I'm just going to simply say 10 plus 12 plus 14, and then I'm going to divide the answer by 2. All right then, so 10 plus 12, that's 22. 22 plus 14, that's going to be 36. 36 divided by 2, that's going to give us 18 centimeter. So that becomes our semi-perimeter. Next, we're going to move to the A part of the calculation where A is then equal to square root. I'm still going to write my formula, guys. I know what it is, but I'm still writing my formula. Don't worry, this is not a 5. It's my S. Don't make that mistake and then say, sir, I think it was a 5. It's a S. So S, open bracket, S minus A, S minus B, S minus C. Close bracket. So then we have the square root of S, which we just calculated earlier to be 18. And then I'm going to open the bracket. I'm going to write 18 again. I'm going to minus the number that I refer to as A, which was 10. Because that's what I call A up here, right here, so 10. I'm going to open the bracket again, 18 once more. And I'm going to take away the next number, which is 12. I'm going to open the bracket for the final time. I'm going to put 18, take away 14. Close the bracket. And ensure that my square root sign goes all the way out. All right, square root then of 18. And from our PEMDAS class, we learned that bracket implies multiplication. So that's 18 multiplied by 18 take away 10. That's going to give us 8. 18 take away 12. Remember, guys, because no one else is sir, that look like R. I know what you guys will say. Sir, that looks like a R. So it was 12, ladies and gentlemen. Let's make that clear from now. This is so small, 12. Okay, so 18 comes back down. 18 take away 10 is 8. Multiplied then by 18 take away 12 is 6. And 18 take away 14 is 4. So then we proceed to just get one digit, one number underneath the square root. That becomes the square root of. And we proceed. Could somebody go ahead and multiply 18 multiplied by 8 multiplied by 6 multiplied by 4?
3,456.
3,456. and 56. Can somebody confirm that?
Yes, sir.
Yes, sir.
Yes, sir.
All right, then you proceed to look on your calculator. We've spoken about this function on this button function. It's usually the one that has a 2, or it's the one that has no 2. Look for that one. Be careful not to press the one with the 3. So go ahead. What is the square root of 3,456?
58.78.
Leon, I'm not hearing that.
58.78.
58.78.
0.78.
What comes after the 8?
7.
So 79. If it's to 2 decimal places, 79. Or you can just say 58.8. Doesn't matter. Squared centimeters. All right? I remember, guys, I have some students that are attempting to do the exam in January. I know that one person is Nevea. And there's another person who sent me a message earlier, right? I sent Nevea the links already to those videos. So you guys can, if you're doing exam in January of 2025, they can access those links and start to watch those past papers from 2024, 2023, 2021. I have more in about the video quality is not that good because I just started YouTube at that time. So I want to do them over. But for now, I have 2023, 2024, 2022, and 2021 available for viewing. All right. And it explains in details multiple ways to work out these problems. All right. In December, I might be able to do the 2024 May, June exam to release it so that can help you guys. Okay. All right. For Heron's formula, for CSEC, we're not going to give you the reverse form for the question. So we're not going to say, find the side A given at the certain, we're not going to do that, right? We can, but we're not going to do that. And if I've never seen it, so there's no point in me showing you a reverse question for the Heron's formula. Most times the Heron's formula, we just kind of just use it to find the area of the triangle. All right. You most likely will get a reverse question on the right angle triangle, or you'll get a reverse question on the formula that I'm going to expose you to now. But should I give you one to try and then have somebody? Yes, I think I should do that. I'm not going to give you a lot of time to do it though. So I'm going to give you 7 minutes. All right, if so much, 7 minutes. And then I'm going to pick somebody at random to walk us through what he or she did. Okay, so have at it, guys. 7 minutes to do this question. Find the area of triangle. You know what? Write it in words, guys. My handwriting is so bad when I have to write all these words. All right, so the question is, find the area of a triangle. I'm giving you in a worded form. Find the area of a triangle with side lengths 14.2 centimeter, 9.7 centimeter, and let me just verify something before I give the other number. What did I just say? 14.2 and 9.7. Hold on, give me a second, guys. 11.3. And 11.3. So side length 14.2, 9.7, and 11.3 centimeter. All right, so go ahead and find the area of that triangle. You can choose to draw a picture, or you can just go ahead and dive right into whatever formula you need to apply to find this area. Go ahead. I'm giving you 5 minutes. All right, because we have to work on time. We have to be very efficient with our calculation. So go ahead, 5 minutes, guys. If you finish, just let me know either in the chat or through your microphone if you're finished. Let's see who first can finish and who can finish first and get the correct answer. It's not a race, but try to be efficient, guys. You can just leave a thumbs up in the chat, or you can just text in the chat that so I'm finished. All right. Remember, guys, the link to last class where we spoke about introduction to algebra, it is now available for viewing. So you can go ahead and watch that. I think I pinned the link in the chat. So you can just click on it now and it'll open your YouTube. And then as soon as you're finished, when you go back on YouTube, you will find it come up on your watch later feed or your homepage. Do I need to pull up back the screen for the numbers? Everybody has the dimensions? 14.2, 9.11.3, and sorry, 14. What did I say? 14.7 or 14.2? 14.2, 9.7, and 11.3. Let's see who first finish and get the right answer. Nevea, how are the videos? How are the videos for the past papers that you've watched already, if you're watching?
I've gotten the time to watch it yet, but I'm going to watch it.
Take your time. Take your time. Take your time. Don't rush it. Oh, I don't see the chat lighting up and telling me that they finished. What is the problem? The decimal is the problem?
Still working.
You have 1 minute. Oh no, I don't see the chat, you know what's going on. And to hear by now, someone should say, sir, I'm finished. We work on our efficiency, guys. Remember that we're working the exam papers in a time frame. So you have to learn to manage with time and be confident in our application of our formulas. Shanika, good job. Let us see if you get it right. It is 8:10. 1 extra minute. Press gas, people. My chat is not going off. Kevon, what's the problem? Miss Barrett, what's the problem? Number 4 student, I don't understand what going on. Never you're stuck?
I'm finished now.
Alright, that's Leah now. Miss Cherry, what going?
Sir, I didn't get some part of the question, so that's why I didn't start it. Sorry.
If you say it to me, man.
I'm
Just
sorry.
tell me.
She didn't reach far ahead, that's why.
Okay.
Alright.
Alright, there you go. Makida. Oh, that's sir to be yeah. Alright, Mr. Lawman finish as well. Kevon, you know, don't finish no long time. We can show up, see. Alright, Kevon, since I finished long time, please take us through this problem. Yeah, man. Yes, man. Come, Mr. Kevon. Remember, you're live on YouTube, so come. Kevon? Mr. Kevon? Alright, Shanika, since you were the first one, because Kevon doesn't want to take up the challenge. Come,
Okay,
Shanika.
sir. Okay, so S equals A plus B plus C divided by 2.
Continue.
So for A, I have 11.3 plus B, which is 14.2, plus C, which is 9.7 divided by 2, and the answer would be 17.6 centimeters.
As in when you add up and divide by 2?
Yes, sir.
17.6?
Mm-hmm.
Okay, good.
Okay. On to the next part. A equals square root S open bracket S take away A close bracket open bracket S take away B close bracket open bracket S take away C equals to 18 open bracket 18 take away 11.3 close bracket open bracket 18 take away 14.2 and 18 take away 9.7 equals to square root square root 18 times 6.7 times 3.8 times 8.3 got a total of equals to square root 3,803.72 And the answer that I got is 61.67, but I rounded it off to 61.7 centimeters square.
I hope you're planning to be a teacher, Shanika.
Well, no, my profession has changed. It
Oh,
was
you were a teacher?
It was thinking about being a teacher, but working for pharmacists.
Both of them are very ambitious. So all the best.
Oh, thank you, sir.
All right, ladies and gentlemen, CSE Shanika just walked us through that problem very articulately. All right, regardless of whether it be a decimal or not.
Excuse me, sir,
Right.
I have a question.
Of course, go ahead.
For what essence she had 17.6 centimeters and then she's
So regarding S, Shanika made an error.
I'm not sure, I'm just saying she had 17.6 and then she used 18 to the button.
Oh, right. So
The
what
answer I
Shanika did is
got,
that, so what Shanika
the
did is that
answer.
Shanika rounded it off to 18. Now,
Oh, okay.
in reality, Shanika shouldn't do that, right? Because she's going to get an answer that is it's going to be within the range, which is going to be acceptable. But unless them tell us if you round off to a whole number, you shouldn't. So I would give Shanika, I would take off a half mark because she rounded it off without being told to do so. So the answer that you have is the correct answer that we will be looking for. It's not that Shanika is wrong, but she did something that wasn't required. So she's getting a slightly inaccurate answer. You're going to get a more precise answer. So
Okay,
you're
sir.
still correct. You're perfectly correct. Okay?
Yes, sir.
Okay.
Sir,
Yes, go
I
ahead,
got
Miss Sherry.
I got stuck at the square root brackets. I miss out
Be
that part.
specific. Line 1, line 2, line 3, line 4, line 5.
Line 2.
Why are we stuck? What happened?
No, that's where I got stuck. I didn't
Meaning that you're clear now?
I didn't remember to put it in bracket here,
Okay.
so I just do a screenshot.
Sir, I don't know where I went wrong, but I got 54.57 as Kevin.
All right.
So I got the same thing, 54.57 centimeters square.
But remember that, are you guys using 17.6?
Yes, sir.
You are correct. That's what I was saying. You're all perfectly correct. Shanika and I didn't even realize until the student earlier pointed it out. She rounded off the answer to a whole number. So her answer is slightly more inaccurate than yours. She's not wrong, but as I said, she rounded off the number when it wasn't supposed to do so. So you guys are going to be more. That's why I'm saying that if the question is worth 3 marks, Shanika would get 2 or 2.5 because it wasn't instructed to round off. So that's it. But you guys are perfectly correct. You never go wrong. You did what was required. Okay? Everybody cool now? Everybody cool now?
Sir, could you work it out with the other answer? Because I'm looking in the chat and everybody getting something slightly different.
All right, let's just use the 17.6 then. So the square root of 17.6, open bracket 17.6 minus, what was that, 14.2? Then 17.6 minus 9.7. And then 17.6 minus What was the last one?
11.2.
What was the last one?
11.2.
Am I correct with all the numbers that I chose? Because I'm not looking back at the screen.
Yes, sir.
All right, so then we have square root of 17.6 multiplied by, Miss Sherry, we're going to subtract the 14.2 from the 17.6 and then write down the result. So we're working out the brackets separately. All right, walk me through. The persons who did the calculation already, talk to me. 17.6 minus 14.2. Jordan, come now.
Yes, sir, and 33.4.
33.
No, 3.4.
3.4.
Oh, okay. I was wondering what's going on. Times, next.
7.9.
Times.
6.3.
So the square root of, what is the product of all those numbers?
2,978.23.
And then your final answer, you stated that it's 50, how much?
4.57 centimeters square.
Good. So perfectly correct. As I said, the answer that Shanika and I got, because I didn't even realize that she rounded it off. The answer that Shanika and I got was because Shanika rounded off 17.6 to 18. So she would have gotten an answer, right? That's what I'm saying, that she would have lost a total of 1 mark. And you guys would have gotten 3, whatever it's worth. She would have lost a whole entire point. Because she would have gotten an answer that perhaps falls right out of the range that we're looking for. All right, everybody cool now? All right, so to lead us into the next class, it's 8:23. All right, the last time we went over by 15 minutes on the deserver, and I feel like the class was good tonight. You guys can get a chance to exit early, but to kick off, so we're gonna kick off next week's class. That is next week Thursday evening. We're gonna kick off our class with a triangle that looks like this, where we have A, we have B, and we have an angle located right here. Call that angle a question mark. We don't know what that angle is, or they tell us what the angle is, and we have to find it here now. This triangle does not have a height, and it does not have a base, and we do not know what all 3 sides are. So, what is the formula for that particular triangle? I hope somebody can research it and come back to us next week and kickstart our class for us. All right, if you find it, come share it. If not, I'll see you guys next week, Thursday, same time, same place, for this particular list. All right.
Theta.
I didn't hear that.
Very good, science theta.
No, we're not going to find theta. Theta will be given to you. Finding theta is going to be trigonometry. So we're not doing that. We're going to be given theta. So theta is going to be like, say, 48 degrees. And we're going to use that information to find the triangle. All right, so that is it. So guys, over the course of the weekend, I'll be sending across the topics that you have to choose for your SBA, along with the image of the topics that I would like you to choose from. It's gonna come with well, we're gonna give you like a few days or a week to pick a topic that you're comfortable with. And then from there, I'm going to be sending screenshots and sample screenshots of how an introduction to a math SB is supposed to be written. All right? And we're going to discuss it. We're going to take 15 or 20 minutes out of the class to run through how to structure an introduction for a math SB. All right, so the SBA work begins next week, starting with you guys picking a topic you're comfortable. If you guys already have a topic from prior math classes, math schools that you went, and you like that topic, feel free to use it, but try not to use a topic that's too common. typing versus writing is a very, very common topic, and CSEC is getting extremely annoyed at people using that topic. So if you can stay far away from that topic, please do. All right. But I'm gonna try to find some nice ones, some easy ones, but nice ones where you can get mathematical calculation out of. Okay. All right. So have yourself a good night, everybody. See you.
Sir,
on the next session. Yes, go ahead.
could you please tell me the topic?